Hi guys, Mr. Kane here for a quick chemistry demonstration. This is going to be law of conservation of mass, or law of conservation of matter, depending on which way you like to talk about it. So the law basically says that in any chemical reaction, matter or mass is conserved. It cannot be created or destroyed. That means that when you start a chemical reaction, the mass before and the mass after should be the same. I've got some calcium chloride here, which I'm going to use to place in the Erlenmeyer flask. Exact amounts are not necessary in this demonstration, so that's probably about enough. Place that on my balance here. In order to have a chemical reaction, we need two chemicals, so I am also going to add some sodium sulfate. I'm going to add it in this test tube. About half full should be good enough. Okay. So I'm going to place the test tube inside the Erlenmeyer flask. Notice that the two chemicals are not mixing yet. I'm also going to use a stopper to stop up the top of the Erlenmeyer. And we are now going to note the current mass on the balance. You should be able to read that. It says 369.1 grams. 369.1. Now, in order to get this reaction to occur, I've placed the stopper on the flask. That way, if there's any gases created, it won't allow them to get out. Also, in order to get this, in order to get these two solutions to actually mix, I have to flip it upside down. So I'm going to flip it upside down, carefully agitate so that the two solutions actually mix. And you can see there's a pretty startling reaction here. When I place this back on the balance, what you're going to notice is that it's the same mass as before, plus or minus a decimal place. 369.2. Okay. Now, the way that I know a chemical reaction happened here is because of two things. Number one, I have a color change. It went from a clear solution to a white solution. The other thing that that's telling me, it's cloudy. So I now have a precipitate that has formed. If you want to see some that we've done before, they're right here. And this actually should give you a good idea of where the word precipitate comes from. We've got this white solid that's created in the middle of the solution, and what happens is it slowly precipitates down to the bottom. So it's kind of like precipitation that happens outside, except for we call it a precipitate. I'm going to go ahead and get a close-up of these so that you can see. Freshly done 6 hours ago, 4 hours ago, 2 hours ago. As you can clearly see, 6 hours ago is lower, 4 hours ago, 2 hours ago is a little bit higher, and right now you can just barely start to see that the precipitate is occurring here. We're getting a slight colorless solution at the top.